problem here that's easier to solve algebraically rather than numerically. Now you'll notice that we'll use the letter n, and n equals 102 is the arithmetic mean. It's the center of the 5 numbers 100, 101, 102, 103, and 104. So with this substitution, we get some origin symmetry, I guess you can call it that, or just some y-axis symmetry, whatever you want to call it, and a lot of stuff cancels out. And namely, all the constant terms cancel out, the n squared terms, a lot of the n squared terms cancel out. And so what we end up with after the end of a lot of mass cancellation is x squared is equal to, we still have this n squared remaining, equals to n squared minus, now notice on this side we have minus 6n, but we also have 6n on this side, so that will result in a minus 12n. Okay, a minus 12n, like this. Okay, and then let's see, we can factor an n out of both sides, so that results in n times n minus 12. All right. Now, so we're trying to solve for x. X is going to be a real number. And so we would get x squared is equal to, again, n equals 102 was the center. I guess you can think of it as the origin. N squared is equal to, or x squared is equal to 102 times 102 minus 12, which is 90, right? Now notice here, let's see. It looks like there's quite a bit of stuff here going away. Let's see, what do we get? That's equal to 2 times 51. 2 times 51, and what, 2 times 45? All right, now again, I'm just trying to get the prime decomposition to work for us right here. And so, x squared would equal to, 2 times 2 is 4, right? So we write 4 down. Now you'll notice here, I'll save a little bit of space here. This is 3 times 17, and this is 3 times 15. All right, and so what we get is 3 squared, which is 9, so we have 4 times 9, right? Then we would have the 17 and the 15 left, right? So that would be times 15 times 17. Okay, and y'all, you can check the arithmetic on that. I think I got it right. Okay, we took out a couple of 2's, then we took out a couple of 3's, and we had 17 times 15 left. And that's what this says. Now notice that this works out relatively nicely because 36 is a perfect square. So we'll get x is equal to plus or minus 6. Y'all, 4 times 9 is 36. Square root of 4 is 2. Square root of 9 is 3. 2 times 3 is 6. And also you have 15 times 17, which is not a perfect square. 15 times 15 is 225. 2 times 15 is 30. 225 plus 30 is 255. And so we can write down the square root of 255 here. Like that, folks. And that's that without a calculator. What do you know about that? Okay, so we do get x is equal to plus or minus 6 times the square root of 255. I think that's correct. And again, we use prime factorizations, no calculators, and we just use the fact that 102 was in the center. It's easier to manipulate everything algebraically and then substitute back in at the end. Hope you enjoyed.